Mono repositories. Large companies like Google, Uber and Netflix use them, and today I'm going to talk why you probably can't afford them yet. This is Tools on Tech, and in this video we are actually getting into a bit more depth than usual. I spent some time during the DevOps days in Amsterdam talking to peers, and after that did some research watching multiple presentations. Links will be in the description. Now I'm going to try and get all that information in this 10-minute video. Quick spoiler warning, it's a complex topic with no straight answer, but I'll give a couple of tips in the end that will help no matter what setup you are on. So let's jump into it. The idea of a mono repository is that everything, documentation, code, dependent libraries, tests, are all in one huge repository. And that comes with a few key benefits. The main one being that every change can be done as one atomic commit. Messing with the API interface on one project? No problem, because you can change the code for all the dependent projects in the same merge request. It also means that once someone has access to the code, they can see all the changes, relationships between projects, and create updates on them without first having to check in or get access. You should be able to find dependencies easy enough if everyone is following the same kind of sane structure. So why isn't everyone using them? Well, if you're a large company, the repository can get very big, and having to clone a couple of gigabytes because you want to update a README file might be a tad overkill. Also, one of the benefits is that everyone has access, but that's also a huge drawback. You might not want everyone to be able to access all the code. Using Git, they will probably have a full copy of everything on their laptop, and this can spell disaster if you've ever got in the wrong hands. Google, for example, has their own repository system to get around that, where only your personal changes are stored locally. It's awesome for them, but most companies just don't have the resources to do that. Another issue is that of testing. You want to test everything, but if you go through the full tree and test everything on any change, you will have plenty of time to learn Spanish while you're waiting for the build test to finish. So, last but not least, there aren't really version numbers. There is always the current latest stable version, but because everything is dynamic, it's hard to tag them with a version for a later rollback. Though some would argue this is a benefit, as only the latest version really matters. But what about multiple repositories then? Do they solve some of the issues? Well, yes, but also no. You get other problems back. Multiple repositories are great because you break up large problems in smaller chunks. This is the whole idea of microservices, for example. Code can be easily checked out as projects aren't too big, and each project can test their own code and build a release. Access to the code can be limited to a subset of people, and by giving builds a version number, it's easier to compare what changed in other projects. Hey, we upgraded awesome library from version 2 to 3 and now our tests are failing. Might be related. But that's also its main drawback. People build stuff at the same time, and at some point you need to release the code and put it together. And if you have too much time between those releases, you might get very weird results. Or even worse, that the last version of library is a dependency of your project but breaks another one, and now everyone has to wait for the fixed version before they can release again. This is also known as dependency hell. Having multiple repositories might also result in not knowing the single source of truth. A library might be with Team A, Bob has his own patched fork, and Team B has its own feature branch. If you don't provide structure here, it might be impossible to decide what version is getting maintained. Finally, if you separate your code, settings, documentation, you will need to do multiple commits and releases just to make a single change, let alone knowing those are related. This is usually what you will find in most companies. People work in small teams, everyone makes their own stuff, and no one is responsible for the work that needs to be done to make it all work together and stay stable. So which one is better? Personally, I think they both have their benefits, but they both require similar work to be able to scale up. When you need to know what version of a library to use in a multi-repository, it's good to have a repository layout structure. In a mono-repository, you need a good directory structure. Testing needs to be broken up, but also linked. So if you update something in your multi-repository, there needs to be some way to test that new code with other projects that are dependent on you. In a mono-repository, you need to avoid tests running against everything, but only do what's needed based on the changes that were committed. So in the end, there isn't a clear answer. It's a hard problem, and in most cases you need to find a way to get from where you are to a better point. A couple of tips to keep in mind. These should all be known company-wide, because these kind of changes need to be cross-team to really get this going. Figure out a structure to work with. Make that part of your repositories. This is easier with a mono repository, as you can just place it in a readme in the root. When using multiple repositories, I would recommend having a master repository that links all other repositories and ties them together, using scripts or systems that fetch these dependencies and test them against each other. Personally, I like Git submodules for this, but because a lot of people don't understand how they work and tend to screw up the connections, it might be better to have something like a requirements text or other software that gets specific versions for a test. Also, build a dedicated team to maintain this master repository. Could be as simple as setting up a build system around it so you can check out the latest version of code and rubbing them together to see if anything breaks. You need the team, however, to be chasing people when stuff is broken. I did something similar when building a Puppet repository, where I used Jenkins and Beaker to build multiple machines to test modules against each other. And we would run this every day, so before stand-up we would know that a change we made yesterday would give issues company-wide. If we would release it as is, that is. Knowing that a day after implementation instead of a month later when you get feedback from other teams saves a lot of time and frustration. One other thing to really keep a clear eye for: how many commits do you need to make a change? If you need to commit to multiple places for a single change, say settings in one place and code on another, then try to figure out how you can combine repositories to get rid of this. It's not only a lot of work, there's a good chance that elements will be missed, and as such should be avoided unless you can explain why it's required. I believe that a change should include variables, tests, code and documentation, and that all this should be in a single pull request. If they all need to be in a different place, then that's something for your build code, not for you to do by hand. It's never a good idea to do stuff by hand. This is why we got into IT in the first place. Thank you for watching the video. Hopefully you're a little wiser on mono and multi repositories. Got any stories on how you solve dependency issues? Be sure to mention them below. Now, I'm releasing a new video every 2 weeks on Monday. If you enjoyed the video, be sure to click on the like button, and if you want to be notified of new videos, then use the subscribe button or click the bell icon. It really helps to keep me going. If you missed something or want to know about a specific topic, be sure to let me know through any of the channels. Links will be in the description below. That's it for now, and remember, you're awesome, keep it up.